Lesson 8.4b, multiplying and dividing rational expressions. Recall that rational expression just means anything that's written as a fraction. So let's start with a simple multiplying example. Suppose that our goal is to simplify or to multiply these two fractions, 2/3 and 5/6. Now, I want to convince you that the first thing you would do when you want to multiply this out is you would take these two fractions and you would break them up into factors. So I'm going to rewrite it this way. 2 doesn't have any factors, neither does 3, neither does 5, but 6 does. 6 we can rewrite as 2 times 3. So see that here I have rewritten the original operation, except for I've just changed the 6 to a 2 times 3. And the value in that is this. We now see that we have a 2 in the numerator and a 2 in the denominator. And 2 over 2 is equal to 1. So we can cancel those two terms out. And then we can multiply across. So in the numerator, we have a 5, and that's it. In the denominator, we have a 3 and a 3 multiplied together, giving us a 9. The answer is 5/9. Now let's look at how what we just did here relates to polynomials. So for instance, suppose instead we were asked to multiply these two expressions. The first one is 15x divided by x squared plus x minus 12. And the second expression is x plus 4 divided by 5x squared. Once again, see how we got rational functions, things written as fractions. Well, just like in the last example, the first thing that we want to do is rewrite this expression by factoring. There's no factoring that we can do in the numerator. There's only one term. However, if we look at the denominator here, we see that we have 3 terms. There is no greatest common factor for x squared, x, and negative 12. So we're simply going to factor it into a pair of binomials. You can use the box method for this. I'm going to tell you what the outcome would be if you do that. We know that the first 2 terms are going to be x and x, so that they multiply to give us an x squared, and that the last 2 terms must multiply to a negative 12 and add up to a positive 1. The numbers that multiply to negative 12 and add up to positive 1 are a negative 3 and a positive 4. So this factored expression here is equivalent to the one above, and I'm going to cross that out. Let's imagine now that our new expression is this divided by this times this divided by this. So we factored. Now let's look to see if we have any cancellation. All right, so let's start here. I have a 15 in the numerator and a 5 in the denominator. So that 5 and that 15 can cancel so that there is a 3 left over. There is an x in the numerator and an x squared in the denominator. So this 1x here can cancel with one of these x's so that there's only 1 left here and there are none left here. Those are gone. Okay. Finally, we have an x plus 4 factor, and we have another x plus 4 factor in the denominator. Remember, they have to be numerator denominator to cancel. So I'm going to cancel those out. And once we do that, let's look at what we've got left. In the numerator, there is nothing but a 3. So my final answer is going to have a 3 in the numerator. In the denominator, let's see, over here we have an x minus 3. And on the second fraction, we have a single x. So I'm going to multiply those together and call that x times x minus 3. That is our final expression. We can't cancel this 3 and this 3 because this 3 is not a factor. It's not multiplied, it's subtracted. So there's our final answer. So we've now looked at a couple of examples that involve multiplying. Let's look at examples that involve dividing. We're going to do 2 of these. First one. Suppose we want to divide the same 2 fractions that we looked at in the first example today. So 2/3 is divided by 5/6. The nice thing about division is that it's really just multiplication in disguise. When you're asked to take 2/3 and divide it by 5/6, that really means we want to take 2/3 and multiply it by the reciprocal of 5/6, which is 6/5. So the first thing we do is we freeze this, we change the sign, and we flip the second fraction so that we get this form. From here, I would take a second step and factor. So 2 has no factors, 3 has no factors, 6 has factors. 6 can be written as 2 times 3 over 5 has no factors. Now we look for cancellation. I see a 3 in the numerator and a 3 in the denominator. We can cancel those. The 2's we cannot cancel because they are both in the numerator. So now we're going to say 2 times 2 gives us a 4, and there is a 5 in the denominator. This division problem is equal to 4/5. So there's sort of a classic division example. Let's now look at an example where we are using polynomials. Example 4, and this will be the last example for today. Suppose that we want to take the fraction 7x's over 2x minus 10, and we want to divide it by the fraction x squared minus 6x divided by x squared minus 11x plus 30. Well, the first thing that we need to do is the same thing that we did on the previous problem. Freeze the first fraction, so write it the same. Change the sign so that it becomes multiplication. And then flip the second fraction so that we get a fraction, but its numerator is going to be the x squared minus 11x plus 30. See, that went to the numerator. And then the original numerator is going to go to the denominator. So here's our new problem. What we want to look at is whether or not we can do some factoring. So I'm going to look around at the pieces. 7x only has one term, so there's no factoring there. In the denominator, 2x minus 10 has two terms, and I notice that 2 is a factor of both. So let's take 2x minus 10 and factor out that 2. If we do, we're going to be left with x minus 5. 2 times x is 2x, 2 times negative 5 is negative 10. Cross that out. Here, let's look at the numerator first. There's no greatest common factor, and we have a trinomial. So for that trinomial, we're going to look at breaking it up into two binomials. We know that we're going to have x, and x is our first terms. X times x gives us x squared. The final two terms are going to be numbers that multiply to 30 and add up to negative 11. And the only numbers that multiply to 30 and add up to negative 11 are negative 5 and negative 6. Go to the denominator. In the denominator, we have a greatest common factor. X squared and negative 6x have an x in common. So let's factor out that x. X times what will give us x squared? X. X times what will give us negative 6x? Negative 6. So look at the expression that we have now. It's kind of messy, but we should note that we have 7x over 2 times x minus 5 times x minus 5. Ooh, that factor shows up again. Times x minus 6 over x times x minus 6. It's time to do some canceling. X cancels with x. They're gone. X minus 5 cancels with x minus 5. X minus 6 cancels with x minus 6. Let's look at what we have left. Almost nothing. In the numerator, there's a 7, and everything else canceled. In the denominator, there is a 2, and everything else canceled. So that original mess at the top of the page simplifies all the way down to 7 over 2. So that concludes our lesson for today. Your assignment, which is going to be due at the bell, is going to be section 8.4, numbers 25 through 43 odd. What I'd like you to do right now is pause the video for a moment and get your book out, get that assignment written down on a piece of paper, and then open up to the assignment, and I am going to get you started on problem number 39. So you should have problem number 39 copied down. If you don't, it looks like this. What can be confusing about a problem like this is that the second term doesn't have a fraction, and we know we're working with fractions here. So what you're going to do if one of the terms doesn't have fractions is you're going to make one. Anything can be divided by 1, and when you divide by 1, that doesn't change the value at all. So this becomes this expression divided by this expression, and then what you're going to do with that is you're going to rewrite it as freeze the first fraction, change the sign, flip the second fraction. And once you get there, you're gonna factor. This doesn't factor. factor this, and once you've done so, there are going to be some things that cancel. So I leave you to complete the problem and to complete the assignment.